Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Review of Python Basics, Part 4, for the Class 12 students of Computer Science. In this video, we are going to have a quick revision on tuples and dictionary. So let's dive in and get started. Let's learn about tuples in Python. What do you mean by the term data structure? A data structure is an efficient way to organize and store data or information. We have learned that lists are data structures that store related data items. Now, we are going to discuss on another Python sequence, tuples. Tuple is a data structure in Python that allows you to store multiple values together as a single entity. It is another sequence data type that is similar to the list. It is an ordered collection of elements. It consists of multiple values in a single variable separated by commas and enclosed within parentheses. Example: open parentheses, red comma blue comma green close parentheses. The values that make up a tuple are called elements. Tuples allow duplicate values. Tuples are heterogeneous, that means tuples can contain elements of different data types. For example, a tuple can have a mix of integers, strings, floats, or other data types. The syntax of tuple is tuple underscore name or variable name equals open parentheses, value 1 comma value 2 comma up to value n, close parentheses. For example, fruits equals apple, strawberry, grapes. In this example, we have a tuple named fruits, with 3 elements, as apple, strawberry and grapes. The elements in a tuple are addressed using their index value. The index value of tuple starts with 0. The main difference between lists and tuples are lists are enclosed in square brackets and their elements and size can be changed, while tuples are enclosed within parentheses and cannot be updated. Tuples are thought of as read-only lists. Let's see some examples. Example 1. Variable tup1 holds a tuple with elements of different data types, a string, an integer, a float, and another integer and printed. Output is a tuple holding Sally and Bytes, 20, 40.05, 250. Example 2. Variable tup2 holds an empty tuple is printed. Output is empty tuple. Example 3. Variable tup3 holds a tuple defined without using parentheses, with 4 integer elements and printed. Output is a tuple holding elements 20, 40, 60, 80. Example 4. A variable tup4 holds a nested tuple containing 2 tuples as its elements and printed. Output is a nested tuple inside a tuple holding elements 10, 20, 30, 40, 50, 100, 150, 200. Example 5. A variable tup5 holds a nested tuple with a tuple and a list as its elements and printed. Output is a nested tuple holding a tuple and a list 20, 40, 60, 80, tuples in Python. Example 6. A variable tup6 holds a tuple containing 2 lists as its elements and printed. Output is tuple holding 2 lists 2, 4, 6, 1, 3, 5. Each tuple is printed to show its contents. Note that each output is enclosed within parentheses as it represents a tuple. Let's revise about singleton tuple. When creating a tuple with a single item in Python, you need to include a trailing comma after the item to differentiate a tuple from a parenthesized expression. Example, my underscore tuple equals 42. In this example, my underscore tuple is a tuple with a single item, the integer 42. The trailing comma after the item distinguishes it as a tuple. Without the comma, it would be interpreted as just an integer value. It's important to note that if you don't include the trailing comma, Python will treat the item as the data type itself, rather than a tuple containing that item. Let's see some examples. Example 1. In this example, my_tuple is defined as a tuple with a single item, the integer 42. The trailing comma after the item ensures that it is recognized as a tuple. When printed, the output shows 42, indicating a tuple containing the value 42. Example 2. In this example, my_tuple is assigned a single value, the integer 42. However, since there is no trailing comma, Python interprets it as an integer rather than a tuple. When printed, the output is simply 42, representing the value of the integer itself. You can check the output and find the difference. Tuples are immutable, that is, we cannot change the elements of a tuple in place. We cannot perform insert, update and delete operations on them. An attempt to modify an element of a tuple yields an error. Let's see some examples. Example 1. In this code, we first define a tuple called my_tuple with 3 elements, 1, 2, and 3. The elements are enclosed in parentheses and separated by commas. This tuple is assigned to the variable my_tuple. Then, we use the print function to display the value of my_tuple on the console. So the output is a tuple holding 1, 2, 3. Example 2. In this example, my_tuple is initially defined as a tuple containing the values 1, 2, and 3. When we attempt to modify the value at index 0 by assigning a new value, 10 in this case, a type error is raised. This error occurs because tuples are immutable, meaning their elements cannot be changed once they are created. The immutability of tuples ensures that their values remain constant throughout their lifetime. If you need to modify a collection of elements, you would typically use a mutable data structure like a list instead. Elements of the tuple can be accessed sequentially using loop. Tuple elements can be accessed using for loop with range function. Tuple indices start at 0. In this example, we have a tuple named my_tuple containing 5 elements. We use a for loop and the range function to iterate over the indices of the tuple. The len function is used to determine the length of the tuple, which gives us the number of elements in the tuple. By iterating over the indices, we can access each element of the tuple using indexing my_tuple of I and print it to the console. The output is 10, 20, 30, 40, 50. Let's see some basic operations of tuple. Now look at these examples. Line 1. The len function is used to calculate the length of the tuple, that is the number of elements. The output is 3. Since the tuple has 3 elements. In line 3, the plus operator is used to concatenate 2 tuples. The output is 10, 20, 30, 40. In line 5, tuple repetition, the asterisk operator is used to repeat the tuple, good, 3 times. The output will be good, good, good. In line 7, the membership in operator is used to check if the value 47 is present in the tuple, 23, 45, 69. Output is false, since 47 is not present in the tuple. In line 9, iteration over a tuple. The for loop is used to iterate over each element of the tuple, 2, 4, 6. The print function is used to display each element x with a space separator. Output is 2, 4, 6. Each element of the tuple is printed on the same line with spaces in between. Tuple slicing is a technique used to extract a portion of a tuple by specifying a range of indices. It allows you to create a new tuple that contains a subset of elements from the original tuple. A slice of a tuple is basically its subtuple. In Python, tuple slicing is done using the square bracket notation. Here's the syntax for tuple slicing. Tuple_name of open square brackets, start, stop, step, close square brackets. Here, start is the starting point. Stop is the stopping point, which is excluded. Step is the step size, also known as stride. Some key points to remember. If start value is not given, slice starts from index 0. If stop value is not given, it will take it to the end. If step value is not given, default value is taken as 1. It includes the first element but excludes the last element. The first value in a tuple is at index 0. You can use the index values in combination with square brackets to access items in a tuple. Tuple slicing is a technique used to extract a portion of a tuple by specifying a range of indices. It allows you to create a new tuple that contains a subset of elements from the original tuple. In this picture, if we consider the positive index, that is forward indexing, index 3, 4, 5 are sliced and a new tuple with elements 40, 50 and 60 are formed. If we consider the negative index of step 1, that is backward indexing, it means to increment the index every time by -1, meaning it will traverse the list by going backwards. Now look at the negative index. Index -5, -6, -7 are sliced and a new tuple with elements 60, 50 and 40 are formed in backward direction. Let's see some examples. Example 1. A tuple with elements of different data types are given. Now look at the top picture. Here, I have marked the positive indexing and negative indexing for this tuple. In positive indexing means forward direction, look at the green arrow in forward direction and follow with me. Index 0 holds a string apple, index 1 holds the integer value 1, index 2 holds a list holding elements 2, 3, 4. Index 3 holds a nested tuple containing 2 strings banana and orange. Index 4 holds a float value 5.5. Now, let's learn the negative indexing that means backward direction. Look at the red arrow in backward direction and follow with me. Index -1 holds the value 5.5, index -2 holds the nested tuple holding 2 strings banana and orange, index -3 holds the list containing 3 elements 2, 3, and 4, index -4 holds the integer value 1, and index -5 holds the string apple. Now, look at example 1, second line. We use tuple slicing to extract a slice from index 2 to index 3, exclusive. The slice, 2:3, includes the element at index 2 but excludes the element at index 3. Since slicing returns a new tuple, the resulting slice is printed as a tuple containing the list 2, 3, 4. I have given a detailed explanation below. Just pause the video and recall the start, stop and step value, with the above indexing picture of the tuple given. Len function returns the length or the number of elements in a tuple. It counts the total number of elements in a tuple. Revise the given examples. Let's revise the min and max function in tuple. Min function shall return the element with minimum value from the tuple. Max function shall return the element with maximum value of the tuple. To use the min and max function, all values in the tuple must be of same type. Revise the given examples. The expression tuple of a seq is used to convert a sequence seq into a tuple in Python. A tuple is an immutable ordered collection of elements, enclosed in parentheses. A sequence can be any iterable object like a list, string, or another tuple. In this example, the list my_list is converted into a tuple using the tuple function. The resulting tuple my_tuple contains the same elements as the original list. As the output is a tuple, it's enclosed in parentheses. Sorted is used to sort the elements of a tuple. It returns a list after sorting. Revise these examples given here. Let's learn about dictionary in Python. A telephone directory can be compared to a dictionary. It is a book that contains names and phone numbers of people. A telephone directory is like a dictionary, where names are the keys and phone numbers are the values. In Python, we can create a dictionary to store similar information as a telephone directory. The names will be the keys in the dictionary, and the corresponding phone numbers will be the values. Now look at this example. A dictionary named telephone_directory holds the key-value pairs of elements. Each name, for example, Sam, Alice, Bob, is a key, and each phone number, for example, 12345678890, 98765432210, 55512345667, is a value. Similarly, in Python 2, we have a concept of key-value pair using dictionary. Python dictionary is an unordered collection of items where each item is a key-value pair. Dictionary in Python is a collection of keys values used to store data values like a map, which, unlike other data types which hold only a single value as an element. You can see in this picture how each key holds a single value as an element. Let's learn about the features of dictionary. Key-value pairs. Dictionaries store data in the form of key-value pairs. Each key is unique and associated with a corresponding value. This allows for efficient and fast lookup of values based on their keys. Each key is separated from its value by a colon, the items are separated by commas, and the entire dictionary is enclosed in curly braces. Mutable. Dictionaries are mutable, meaning that you can modify, add, or remove key-value pairs after the dictionary is created. This flexibility makes dictionaries useful for dynamically changing data. Unordered. Dictionaries are unordered, which means that the order of key-value pairs is not guaranteed. The order in which the items are stored in a dictionary may vary and is not important for their retrieval. Flexible key types. Dictionary keys can be of various data types, such as strings, numbers, or even tuples. However, keys must be immutable types because they are used as hash values to access values quickly. Arbitrary data types for values. Dictionary values can be of any data type, including numbers, strings, lists, other dictionaries, or even custom objects. This flexibility allows dictionaries to store and retrieve a wide range of information. No duplicate keys. Dictionaries cannot have duplicate keys. If you try to assign a value to an existing key, it will replace the previous value associated with that key. Let's learn how to create a dictionary. To create a dictionary in Python, you can use curly braces and specify key-value pairs separated by colons. Syntax is dictionary_name equals open curly braces key 1 colon value 1 comma, key 2 colon value 2 comma, key 3 colon value 3, upto, key n, colon value n, close braces. Let's see some examples. Now, look at example 1. In the line my_dict equals curly braces, you are creating an empty dictionary named my_dict. In this case, by assigning curly braces to my_dict, you are initializing an empty dictionary with no key-value pairs. This provides you with a dictionary object that you can populate with data later on by adding key-value pairs. Now, look at example 2. The line creates a dictionary named my_dict1 with 4 key-value pairs. Key R, value rainy. This key-value pair associates the letter R with the value rainy. Key S, value summer. This key-value pair associates the letter S with the value summer. Key W, value winter. This key-value pair associates the letter W with the value winter. Key A, value autumn. This key-value pair associates the letter A with the value autumn. Let's see some examples. Example 1. In this code, an empty dictionary named my_dict is created using curly braces. The printf my_dict statement outputs an empty dictionary. Since no key-value pairs are added, the dictionary is empty. Example 2. In this code, a dictionary named my_dict1 is created with 3 key-value pairs. I have marked key value pairs in pink color for your reference. The keys are integers, 100, 200, 300, and the corresponding values are strings, red, blue, green. The print statement outputs the dictionary my_dict1 with its key value pairs. The output is 100:red, 200:blue, 300:green, enclosed in curly braces. Example 3. In this code, a dictionary named my_dict2 is created with 4 key value pairs. I have marked key value pairs in pink color for your reference. The keys have different data types. An integer, 1, a string, 2, a tuple, 3, 4, and a float, 3.14. The corresponding values are integer, string, tuple, float. The printf statement outputs the dictionary my_dict2 with its key value pairs. The output displayed is 1:integer, 2:string, a tuple holding values 3, for tuple, 3.14 float, enclosed in curly braces. To access elements in a dictionary in Python, you can use square brackets along with the keys of the dictionary to retrieve their corresponding values. Let's see some examples. Example 1. In this line, a dictionary called my_dict is created with 3 key value pairs. Key, name, value, Nancy. Key, age, value, 12. Key, city, value, New York. The next line prints the value associated with the key name in the dictionary my_dict. You can see the square brackets used along with the key name of the dictionary to retrieve the corresponding name. Since the key name exists in the dictionary, the output will be Nancy. Example 2. This line prints the value associated with the key age in the dictionary my_dict. The key age exists in the dictionary, so the output will be displayed as 12. Example 3. This line tries to print the value associated with the key grade in the dictionary my_dict. However, the key grade does not exist in the dictionary, so an error will occur as key error, grade. Let's learn about traversing a dictionary. To traverse or iterate over a dictionary in Python means accessing each element of a dictionary. This can be done by using a for loop. Iterating over keys using a for loop. You can use a for loop to iterate over the keys of the dictionary. Within the loop, you can access the corresponding values using the keys. Let's see an example. In line 1, a dictionary called my_dict is created with 3 key value pairs. Key, name, value, Nancy. Key, age, value, 12. Key, city, value, New York. In the second line, this code uses a for loop to iterate over the keys of the dictionary my_dict. During each iteration, the current key is stored in the variable key. The line value equals my_dict key retrieves the value associated with the current key and assigns it to the variable value. Finally, the print statement prints the key, a colon, and the corresponding value. The output will be name: Nancy, age: 12, city: New York. The for loop iterates over each key in the dictionary, and for each key, it accesses the corresponding value. Thus, the loop effectively traverses the dictionary and prints each key value pair. Let's learn about appending values to a dictionary. To append or add values to the existing dictionary in Python, you can extend it with single pair of values or join 2 dictionaries into one. Syntax is dictionary_nameof, key equals value. Now look at the example. In the first line, a dictionary called my_dict is created with 4 key value pairs. Key, mon, value, Monday. Key, to, value, Tuesday. Key, wed, value, Wednesday. Key, thurs, value, Thursday. The second line adds a new key value pair to the dictionary my_dict. The key fry is assigned the value Friday. Since the key fry doesn't exist in the dictionary, a new key value pair is appended. The third line prints the dictionary my_dict after adding the new key value pair. The output will be, open curly braces, Monday, 2 Tuesday, Wednesday, Thursday, Friday, close curly braces. To update elements in a dictionary in Python, you can modify existing key value pair or by merging another dictionary with an existing one. Syntax is dictionary_name of key equals value. Now, look at this example. In the first line, a dictionary called my_dict is created with 3 key value pairs. Key, name, value, Nancy. Key, age, value, 12. Key, city, value, New York. The next line updates the value associated with the key age in the dictionary my_dict. The line my_dict of age equals 13 assigns the new value 13 to the existing key age. After the update, the dictionary is printed using print of my_dict. The value associated with the key age is updated from 12 to 13. The dictionary my_dict is modified, and the updated dictionary is printed. The output displayed is open curly braces, name Nancy, age 13, city New York, close braces. Now, look at example 2. This code adds a new key value pair to the dictionary my_dict. The line my_dict of grade equals A assigns the value A to the new key grade. Since the key grade doesn't exist in the dictionary, a new key value pair is added. After the addition, the dictionary is printed using print of my_dict. Output displayed is open curly braces, name Nancy, age 13, city New York, grade A, close braces. The dictionary my_dict now contains 4 key value pairs, including the newly added key grade with the value A. 2 dictionaries can be merged into one by using update method. It merges the keys and values of one dictionary with another and overwrites values of the same key. Syntax is dic_name1.update of dic_name2. Using this, dic_name2 is added to dic_name1. Now, look at example 1. In this example, dict1 and dict2 are initially separate dictionaries. After calling dict1.update of dict2, the key value pairs from dict2 are merged into dict1. The resulting merged dictionary is A:1, B:2, C:3, D:4, enclosed in curly braces. However, dict2 remains unchanged. The output of dict2 is C:3, D:4, enclosed in curly braces. Now, look at example 2. In this example, both dict1 and dict2 have a common key value pair. When dict1.update of dict2 is called, the value of the common key B in dict1 is overwritten by the value from dict2. The resulting merged dictionary is A:1, B:5. Again, dict2 remains unchanged. The output of dict2 is A:1, B:5, enclosed in curly braces. The update method merges dictionaries by adding or overwriting key value pairs from the second dictionary into the first dictionary. The original dictionaries are modified in place, and any modifications to one dictionary do not affect the other. Let's learn about removing an item from dictionary. To remove an item from a dictionary in Python, you can use the del command or the pop method. First we will learn using the del command. The syntax is del dict name of key. Let's see some examples. Example 1. In this example, a dictionary named my_dict is created with 4 key value pairs representing different fruits and their quantities. The print function is used to display the initial contents of the dictionary. The output shows the dictionary with all its key value pairs. Apple: 3, banana: 5, orange: 2, grape: 4, enclosed in curly braces. Now, look at example 2. Here, the del statement is used to remove the item with the key banana from the dictionary my_dict. After removal, the updated dictionary is displayed using the print function. Apple: 3, orange: 2, grape: 4, enclosed in curly braces. As shown in the output, the item with the key banana is no longer present in the dictionary. Now, look at example 3. In this part of the code, an attempt is made to remove an item with the key cherry from the dictionary my_dict using the del statement. However, since the key cherry does not exist in the dictionary, it will result in a key error being raised. The code will terminate at this point and the key error message will be displayed. The key error is raised because del my_dict of cherry is trying to remove an item with a key that does not exist in the dictionary. Let's revise the built-in dictionary functions. In Python, the len function returns the number of items or elements in a collection, such as a string, list, tuple, or dictionary. When used with a dictionary, the len function returns the number of key value pairs in the dictionary. The syntax is len of d. Here, d is the dictionary. It returns number of key value pairs in the dictionary. Revise these examples here. In Python, the clear method is used to remove all the elements from a dictionary. It modifies the dictionary in place, resulting in an empty dictionary. Revise these examples here. In Python, the items method is used to return a view object that contains tuples of key value pairs from a dictionary. Each tuple represents a key value pair, where the first element is the key and the second element is the corresponding value. The syntax is d.items function. Here d is the dictionary. Revise these examples here. In Python, the keys method is a dictionary method that returns a view object containing the keys of the dictionary. Note that keys returns a list of the key values in a dictionary. Lists are enclosed in square brackets. Syntax is d.keys function. Here, d is the dictionary. Revise these examples here. In Python, the values method is a dictionary method that returns a view object containing only the values of the dictionary. The syntax is d.values function. Here, d is the dictionary. Revise these examples here. In Python, the copy function is used to create a shallow copy of a dictionary. It returns a new dictionary object that contains the same key value pairs as the original dictionary. We cannot copy a dictionary by using assignment equal to operator, as it will create a reference to the same dictionary variable and modifications will also be reflected in both dictionaries. We can use built-in function copy to create a new dictionary and modifications done on base dictionary will not be reflected. The syntax is dict_new equals dict_old.copy function. Revise these examples given here. Let's learn about Fromkey'S method in dictionary. In Python, the Fromkey'S method is a built-in method available for dictionaries. It is used to create a new dictionary with specified keys and a default value for all the keys. The syntax is new_dict equals dict.fromkeys of keys, value. Here, keys is an iterable, such as a list or tuple, containing the keys for the new dictionary. Value is the default value assigned to each key. The Fromkey'S method returns a new dictionary with the specified keys and default value. Revise these examples given here. The setDefault method is used to retrieve the value of a specified key from a dictionary. If the key exists in the dictionary, the method returns its corresponding value. If the key does not exist, the method creates a new key-value pair with the specified key and a default value, and then returns the default value. The syntax is dictionary.setDefault of key, default _ value. Here, key is the key to be searched in the dictionary. Default _ value is the value to be set as the default if the key is not found. None if key is not in the dictionary and default _ value is specified. Revise these examples given here. Thanks for watching. Watch the upcoming videos. Review of Python Basics, Part 5. Bubble sort and insertion sort. You can check the link in the description box below.